Hi kids, in this video we'll continue with class 9 mensuration exercise 16.3. We have already done till sum number 30. Okay, area of circles. Now see, 31 part A, this is a figure given. They have told that ABCD is a square of side 14 centimeter and ABCD are centers of the equal circle, which means the radius is same for all the 4 circles. Find the area of the shaded region. Now look carefully. I'll just draw one part. So if we draw one part, see, the shaded region is nothing but 3/4 of a circle. So the area of this part will be 3/4 of the area of the circle, isn't it? Which means this part, this and this. Area of these 4 parts will be 4 multiplied by 3/4 the area of a circle, isn't it? Plus I'll add the area of the square, minus area of 4 quadrants, that will give me the area of the shaded region. Look carefully. I just solve it. Actually, look over here. The side of the square was 14, which means the radius of the circle will be 7 centimeter, because this is 7 and this is 7. Okay, so this so area of the shaded region is 3 multiplied by 22 by 7 multiplied by r square, that's 7 square is 49, plus area of square will be 14 multiplied by 14, that's side square, minus area of 4 quadrant is again 4 multiplied by pi r square by 4, isn't it? Or area of a circle, and area of 4 quadrant is same. So this and this cancels out. 7 ones are 7 sevens are. So that's 66 multiplied by 7 plus 196 minus this is 22 by 7 multiplied by 7 square, that's 49, 7 times. This is 6 sevens are 42, that's 46 plus 196 minus 154, that's 462, plus this is how much? This is 42, that's 504 centimeter square. So that's the area of the shaded region. Okay, you just need to find the area of these 4 part, which was 4 times 3/4 of the area of a circle, area of a square minus area of 4 quadrant. Clear? Now let us look at the next sum. Now if you look at 31 part B, it consists of 3 semicircular region or arc, you can say. The bigger one, diameter of the larger semicircle they have given, that is, suppose this is A, B and this is O. So AB is given as 10 centimeter. They have told one more thing, smaller semicircular arcs are equal, which means this semicircle and this semicircle have the same diameter, which means AO will be clearly 5 centimeter and OB will be also 5 centimeter. What they have asked? Length of the boundary of this shaded region as well as area of the shaded region, and they have told use pi as 3.14. Pretty easy. Just look over here. When you talk about the boundary from, suppose this is from ACD, this arc, if you see, that's the semicircle. Okay, so the circumference of the semicircle, this part, will be 2 pi r by 2, because for the whole circle the circumference is 2 pi r. So for the semicircular region, this part will be pi r, 2 pi r by 2, that's pi capital R. For this region similarly, it will be pi small r, and for this region also it will be pi small r. That will be the length of the boundary. So length of the boundary will be pi capital R plus pi small r plus pi small r. So this will be equal to pi taken common, r plus r plus r. That's pi r plus 2r. Now look carefully, this is 3.14. The radius of the bigger semicircular r is 5 plus 2 into the radius of the smaller semicircle will be 5 divided by 2, that's 2.5, isn't it? Capital R is 5 and small r is 2.5 centimeter. So this will be 3.14, 5 plus 5, that's 3.14 multiplied by 10, that's 31.4 centimeter. Done. That's the length of the boundary. Then they ask the area of the shaded region. Now look carefully. Area of the shaded region will be area of the big semicircle, area of big semicircle minus this part, which is area of small semicircle, plus this part, which is area of again small semicircle. And since the small semicircle have equal radius as similar, so this and this cancels out. So what is the area of the shaded region? It's simply area of the big semicircle, which is pi r square by 2, isn't it? Okay, so just put the values. So this is 3.14, r square is 5 square by 2, so that's 3.14 multiplied by 25 by 2 centimeter square. You can calculate this easily. Am I clear? Or simply you can see now, if you displace this part over here, this becomes a complete semicircle with radius 5. Clear? Now let us look at the next sum. Now look at 32 part B. 32 part A is similar to 31. Okay? Now look over here. They've given a square A, B, C, D. Inside it, there's a circle with diameter 2 centimeter. At the corners, there are 4 quadrants of equal radii. That is 1 centimeter. Okay? They've told us to find the area of the shaded region. Pretty easy. Area of shaded region will be area of the square. Just look carefully. Area of square minus area of a area of a circle minus area of 4 quadrants minus area of 4 quadrants, isn't it? Now area of the square, this is 4, so that's 4 multiplied by 4. Area of a square circle, sorry, will be, the radius is of course 1 centimeter, so that's pi r square, that's 1 square, minus area of 4 quadrant will be 4 multiplied by pi r square by 4, which is area of a circle only. Again, this is 16 minus pi minus again pi, and r is 1. Look carefully. So that's 16 minus 2 pi. This pi into 1 will be pi. So that's 16 minus 2 multiplied by 3.14. That's 16 minus 6.28, isn't it? That's how much? That's 9.72. Is it correct? Yeah. This centimeter square. Done. Pretty easy. Just find the area of the square, subtract this circle and this 4 quadrant, we'll get the area of the shaded region. Clear? Now let us look at the next sum. Now look at sum number 33 part A. Pretty easy. From a rectangle you can see ABCD. AB is 14 centimeter and BC is 7 centimeter. A semicircular region, okay, and a quadrant has been cut out. They've asked for the area of the remaining piece, okay, which means this part. Pretty easy. Area of the remaining piece will be area of rectangle minus area of semicircle, isn't it, minus area of the quadrant, area of quadrant, isn't it? And if you look carefully, for the quadrant, the radius is 7 centimeter, and for the semicircle, the diameter is this. See, this is 7, so this will be also 7 because the entire thing is 14. So the radius is 7 by 2 centimeter, isn't it? Just use it. Area of the rectangle will be 14 multiplied by 7 minus area of a semicircle will be pi r square by 2. So that's pi r square. R is what? 7 by 2 whole square by 2 minus area of the quadrant will be pi r square. That's 7 square by 4. Isn't it? Just put the value. This is 98 minus this is 22 by 7 multiplied by 2 multiplied by 49 by 4. Isn't it? And this is 22 by 7 multiplied by 4. This is 49. Am I correct? So that's 98 minus this is 11 times. This is 7 times. So that's 77 by 4 minus this is 2 times 11 times 7 ones are 7 sevens are, that's 77 by 2. Am I correct? So that's 77 by 4, it's 19.25, isn't it? 4 ones are 4 nines are, yeah. And this is 3 times 8 times 50, isn't it? So you just calculate this. So this is 98 minus this is point, this is 75, this is 7, 5. So that 57.75. Isn't clear? So you just subtract it. I'll just subtract it. See, this is 98.00 and this is 57.75. So that's how much is left. This is 40.25 centimeter square, and that's your answer. Pretty easy. Just subtract this area and this area. Okay. Now let us look at the next sum. Now look at 33 part B. They have given a kite where BCD, this region, is a quadrant of radius 42. Okay, so this will be, CD will be 42. That's the radius of that quadrant. ABCD is a square. Definitely the side of the square is 42 centimeter. CEF is an isosceles right angled triangle whose equal sides are 6 centimeter. So if I'll just enlarge it, then of course this is 90 degrees. So this will be 90 degrees. And the equal side has to be this and this, because this becomes a hypotenuse, isn't it? Find the area of the shaded region. Pretty easy. Area of the shaded region will be area of the quadrant, just look carefully, plus area of the triangle, isn't it? Area of the quadrant is pi r square by 4, and area of triangle will be half into base into height, isn't it? So this is 22 by 7 multiplied by r is 42 whole square by 4 plus half multiplied by base is 6, and the height is also 6 in this case. It's a right angle triangle, okay? The equal side, one of them becomes a base, one of them becomes the height. So that's 22 by 7 multiplied by 42 into 42 multiplied by 4 plus this is 18. This 4 to 11 to 21, 7, 3 times. So that's 33 multiplied by 42 plus 18. I hope you can do this, okay? So that's the area of the shaded region. Clear? Just this quadrant plus the triangle. Now let us look at the next sum. Now let us look at 34 part A. There are 3 semicircular region, if you can see. Okay, actually there are 4, but these 2 are equal. Okay, they're given the diameter of the largest semicircle is 14, which means if I take this AB, then AB is 14 centimeter. Diameter of the smallest semicircle, so if I take this as suppose EF, then BF is equal to AE is equal to 3.5 centimeter. So this is 3.5, this is 3.5, the entire is 14. So this has to be EF has to be 7 centimeter. 14 minus 3.5 minus 3.5. Now look carefully what they've asked. The length of the boundary of the shaded region, okay, and the area of the shaded region. Pretty easy. If you talk about this part, this region, okay, the biggest semicircle, the circumference will be pi r, pi, and the radius, since the diameter is 14 pi r, so that will be equal to 22 by 7 multiplied by 7. So that's 22, isn't it? Now look carefully. If you talk about this part, the smallest semicircle, okay, there the circumference, this region, okay, will be pi small r, suppose. So, and small r is 3.5. So this is 22 by 7 multiplied by, sorry, small r is 3.5 by 2 because 3.5 is the diameter. So that's 3.5 by 2, isn't it? So that's become 11. This is 0.5. That's 5.5 centimeter. Similarly, for this region also, the circumference, this part will be 5.5 centimeter. Okay, and this region, if you see, okay, where the diameter is 7, okay, so the circumference will be pi r, okay, r1 suppose, so that's 22 by 7 into the radius is 3.5, so that's 2 times, that's 11. So this is how much? 11, isn't it? So the length of the boundary will be 22 plus 5.5 plus 11 plus 5.5. That's how much? That's 44 centimeter, isn't it? That's the length of the boundary. Now they are talking about area of the shaded region. Now area of the shaded region, if you look carefully, will be area of the largest semicircle, which is pi r square. R is 7, r square by 2 minus area of this semicircular region, which is pi, and the radius is 3.5 by 2 whole square by 2, okay, minus this region, again pi r square by 2. Am I clear? Plus the area of this region, which is pi, and the radius is 7 by 2 whole square by 2. Am I clear? So that will be the area of the shaded region. You just substitute the value and get the answer. This is equal to, this is 22 by 7 multiplied by 49 by 2 minus this, and this are similar. So twice of this I can write, see, that becomes pi 3.5 by 2 whole square only, and this is just substitute the value. You can solve as per your wish, okay. That's 49, okay, by 4. Am I clear? I'll just simplify it further. This is 11, so this is 77 minus, this is 22 by 7 multiplied by 3.5 multiplied by 3.5 by 22, that's 4, plus this is 7 times 2, 1, 2, 11 times, that's 77 by 4. Am I clear? So that's 77, this is 0.5, this is 2, this is 11 times, isn't it? minus 11 multiplied by 0.5 multiplied by 3.5 by 2 plus that is 4 ones are 4 nines are 36 19.25, isn't it? Am I clear? Now just simplify this. I think this and this will be added, so 77 plus 19.25 minus this will be subtracted, and that is 5.5 multiplied by 3.5 by 2, that's 9.625. 9.625. Just calculate this and you will get the answer. Simple. Okay, the shaded region area of the largest semicircle minus these two plus this. Simple. Okay, now let us look at the next sum. Now look at this sum, 34 part B. They have given a trapezium ABCD. AB is parallel to CD, and they have given AB is 3.5, BC is 3.5 centimeter, okay, and DE is 2 centimeter. From this trapezium, a quadrant BFEC is removed. Find the area of the shaded region or the remaining part. Pretty easy. See, area of the remaining part will be area of trapezium minus area of quadrant, isn't it? Area of trapezium, if I remember, is half multiplied by sum of parallel sides multiplied by distance between them, which means perpendicular distance between parallel sides, minus area of the quadrant is pi r square by 4, isn't it? Pi r square by 4. Just substitute the value. Now look, first of all, BC is 3.5. That's the radius of this quadrant. So EC will be 3.5 centimeter, which means DC, look at the calculation, this is 3.5 plus 2. That's 5.5 centimeter, which means the parallel sides of this trapezium is 3.5 and 5.5. So it becomes half 3.5 plus 5.5 multiplied by perpendicular distance, which in this case is 3.5 minus pi, that is 22 by 7. Radius is 3.5 whole square by 4. Done. This is half multiplied by this is 5, 6, 7, 8, 9 multiplied by 3.5 minus this is 22 by 7 multiplied by 3.5 multiplied by 3.5 by 4. Just calculate this. This is 4.5. So that's 4.5 multiplied by 3.5 minus this is 0.5, and this is 2 times, this is 11 times. So that's 11 multiplied by 0.5 multiplied by 3.5 by 2. Am I correct? So now you can do your calculation very easily. 4.5 multiplied by 3.5 will be 15.75. Okay, and 11 multiplied by 0.5 is 5.5. Then 5.5 multiplied by 3.5 by 2 will be 9.625. 0.625. Just subtract the 2 and get the answer. Clear? It was very easy. Just remember the formula for the trapezium. It's half into sum of parallel side into perpendicular distance between the parallel sides. Clear? Now let us look at the next sum. Now look at 35 part A. There is a right angle triangle ABC in which AB is 28, BC is 21. Okay. With AC as the diameter, we draw a semicircle, and with BC as a radius, we draw a quadrant. They have asked for the area of shaded region. Pretty easy. Area of the shaded region will be area of semicircle. Look carefully. Area of semicircle plus area of triangle minus area of quadrant, isn't it? I'll just give the hint, you can do it on your own. Area of the semicircle is pi r square by 2, pi r square by 2 plus area of the triangle will be half multiplied by base multiplied by height, and area of the quadrant is pi r square by 4. Now what is capital R. Okay, that's AC. We can get AC by Pythagoras theorem. So AC square is equal to AB square, that's 28 square plus 21 square. Am I correct or not? So 28 square is 784 and this is 441. So AC square will be, this is 51225, isn't it? Yeah. So AC will be root of 1225, that's 35. Done. Which means capital R is 35 centimeter and small r is of course 21 centimeter. Oh sorry, capital R will be 35 by 2 because 35 is the diameter. Now just substitute the value, that's 22 by 7 multiplied by R is 35 by 2 whole square, divide by 2, isn't it? Pi R square by 2 plus this is 14 times, that's 21 multiplied by 14 minus pi R square by 4. What is R? R is 21. So just calculate the value, okay, and get the answer. I just gave hint over here. Calculation, you try it on your own. Simple, it was this semicircle plus triangle minus quadrant. Look, that will give you the area of the shaded region. And how to get the diameter, that is AC by Pythagoras theorem. Okay. Now let us look at the next sum. Now let us look at 35 part B. There's an equilateral triangle ABC with the sides 8 centimeter. From that, 3 sectors are cut out. And if you look carefully, all the angles are 60 degree. So the angle of these sectors are 60 degree. Remember that. Now just a note that area of a sector, suppose you have something like this, a part of a circle, suppose this is theta, that's theta by 360 multiplied by pi r square. Pretty simple, okay? So area of the shaded region over here is nothing but area of triangle minus area of 3 sectors, if you see carefully. The area of the triangle, that's an equilateral triangle, that's root 3 by 4 side square, that is a square, a represents the side, minus area of 3 sectors, 3 multiplied by area of, suppose this sector will be 60 by 360 into pi r square. And look carefully, the entire thing is 8, so this has to be 4 because the sectors are equal angle. Okay, so the radius have to be same, 4. Just substitute the values, that's root 3 by 4, that's 8 square minus, this is 1 by 6, so 3 by 2, this is 22 by 7, r is, this is 4 square by 2, okay, that's root 3 by 4, you do the calculation, okay, that's 11 times, that's 11 into 16 by 7, okay. Oh, actually they have told pi to use as 3.142. So what you do over here, you just substitute, that is, this is pi is 3.142 multiplied by r square, r is 4 square by 2. Okay, so that's 3.142 multiplied by 16 by 2, that's 8. That's 16, so that's 16 multiplied by root 3, that's 1.732 minus 3.142 multiplied by 8. I think you can do this calculation. Okay, just area of the right angle, equilateral triangle minus the 3 sectors. Sectors, the area is theta by 360 multiplied by pi r square. Just remember that, okay? Now let us look at the next sum. Look at this sum. 36. A circle is inscribed in a regular hexagon of side 2 root 3 centimeter. Find the circumference of the inscribed circle and the area of the inscribed circle. Just remember one thing, that in case if the circle is inscribed in a hexagon, regular hexagon, okay, then you look, OAB is a equilateral triangle and the radius, suppose OD, in this case is nothing but the altitude of the equilateral triangle. So what will be OD? Root 3 by 2 into the side of that equilateral triangle, which is AB. This is the radius, remember that? Okay, we have done earlier how to calculate the altitude in the equilateral triangle. So radius will be root 3 by 2, and the side of this hexagon, which it will be the side of the equilateral triangle which I have drawn, AOB, is 2 root 3. So that's 3 centimeter. You got the radius of the inscribed circle. Once you get the radius, circumference is 2 pi r. Okay, that's 3. That's 132 by 7 centimeter, and the area is nothing but pi r square. That's 22 by 7 into 9, because 3 square will be 9, 18, 198 by 7 centimeter square. This was important. The radius will be root 3 by 2 multiplied by the side of the regular hexagon. Okay, OAB is an equilateral triangle. Remember that. Okay. Now let us look at the next sum. Now look at this sum, 37, the last sum for this exercise. There's a circle with a chord AB, and the chord AB makes an angle 90 degree with the center. The radius of this circle is 10 centimeter. They've asked the area of the sector OACB. So area of sector OACB. Now if you look carefully, OACB, since this is 90 degree, is nothing but a quadrant. So the quadrant will be pi r square by 4. Pretty easy. That's, they have told pi to use as 3.14 multiplied by 10 square is 100 by 4. So that's 314 by 4 centimeter square. You can change it to a decimal. Okay, that's pretty easy. Now they're asking, they ask for the area of the sector OACB, done, and of the major segment. Now look carefully. First of all, AB divides the entire circle into two segments. This is the minor segment and the rest is the major segment. In a circle we have done, if this is a chord which is not a diameter, then this is your minor segment and this is your major segment. So they have asked for the area of the major segment. The first thing, we can easily get the area of minor segment. See, area of minor segment, if you look at the diagram carefully, is area of the quadrant minus area of the triangle, which is a right angle triangle whose angles, if you see, whose sides are, base and height will be 10 centimeter each. So first of all, area of the quadrant is 314 by 4 minus area of the triangle will be half into base into height, which is again 10. Is it clear? So this will be how much? This we calculated, okay? This is 2 times 157. If I'm not wrong, see? Yeah. And then again, so 2 7 times 76.5 minus 50. So that's 26.5 centimeter square. That's the area for the minor segment. So what will be major segment? The area of major segment. Area of major segment will be area of the circle. Area of circle minus the area of minor segment, which is 26.5, and area of a circle is pi r square, that's 3.14 multiplied by r square. R square means 10 square is 100 minus 26.5, that's 314 minus 26.5. I hope you can do this calculation. Okay, it was pretty easy. Just you need to know what is a minor segment, what is a major segment. Clear? So keep it till here in this video. In the next video, we'll look at some other chapter. Till then, take care.